Welcome to Lesson 10.6. Here is the spiral review from Lesson 10.5. Please go ahead and take a moment to check your answers. If you are on the live feed and have questions about how to get to these answers, we'll talk about it. If you are watching the recording, please email me if you need further help. Today's learning goal is to practice using the strategy Make a Table to help you solve problems about customary and metric conversions. Let's unlock the problem. Aaron is making fruit punch for a family reunion. He needs to make 120 cups of punch. If he wants to store the fruit punch in gallon containers, how many gallon containers will Aaron need? Use the graphic organizer below to help you solve the problem. Well, if I take a look, I'm noticing right away there's a mistake. Someone at the book company must have been having a bad day. This should be just one here, and I think that that is how it is in your books. So if I take a look at this, the way I read this conversion table is, notice down the side I have gallons, quarts, pints, cups, and across the top I have gallons, quarts, pints, and cups, and I read it just like I would a multiplication table. I read across and then from the top down. So 1 gallon, of course, equals 1 gallon. 1 gallon equals 4 quarts. 1 gallon equals 8 pints. 1 gallon equals 16 cups. 1 quart, it's just 1/4 of a gallon. 1 quart equals 1 quart. 1 quart equals 2 pints, and 1 quart equals 4 cups. 1 pint is just 1/8 of a gallon. 1 pint is 1/2 of a quart. 1 pint equals 1 pint, and 1 pint is 2 cups. And then finally, 1 cup is 1/16 of a gallon. That makes sense, right? Because it takes 16 of them to make the gallon. So 1 cup, when I compare it to the gallon, it's just 1/16 of the gallon. 1 cup is 1/4 of a quart. 1 cup is 1/2 of a pint, and 1 cup, of course, equals 1 pint. If you would, pause the video to fill out the boxes below. What do I need to find? What information do I need to use? And how will I use that information? Then join us to talk about the problem. What do I need to find? Well, I need to find how many gallon containers can be filled with 120 cups of punch. And what information will I use? The problem tells us that we need to use the number of cups that were made, which was 120 cups, and the number of cups in 1 gallon. And if I look at the chart above, I can see that there are 16 cups in 1 gallon. How will I use this information? I will make a table to show the relationship between cups, and here you see it. Here are the cups and the number of gallons. So relationship of cups to gallons. I know that there are 16 cups in 1 gallon. So each cup is 1/16 of a gallon. And then I just complete my table. 1 cup is 1/16 of a gallon, excuse me. So 2 cups, that's twice as much. 2/16 when I simplify it is 1/8. 3 cups would be 3/16. 4 cups, that's 4/16, which when I simplify it is 1/4. So my rule, it's easiest to see right here, is simply to multiply by 1/16. So when I multiply 120, and I'm going to put that over 1, times 1/16, that equals 120/16, which when I simplify it, the easiest way to go about that is simply to say 120 divided by 16. Well, there are 7 of those 16s. 7 times 6 is 42. Carry the 4, 7, put a little one right there. 7 times 1 is 7, plus 4 more is 11. So now I subtract 112 from 120. That leaves me with 8. I'm going to write that as a fraction. I have 8 left over. My divisor is 16. When I simplify 7 and 8/16, that's really like saying 7 1/2. So in order to be able to carry all of those 120 cups of punch, I'm going to need 7 1/2 gallon containers. The problem with that is he only has gallon containers, so it's going to take Aaron 8 gallon containers to store the punch. Use reasoning. Will all of the gallon containers Aaron uses be filled to capacity? That's simply a way of saying, will they all be full? Well, if he only needs 7 1/2, if he only has 7 1/2 gallons of punch, at least one of those jugs is not going to be completely filled, right? It will be just half full. So we could just say one jug or one container. I'm going to write jug, save some space here, will be, be half full. 7 completely filled. Let's try another problem. This time we have the conversion table that is meters. So we'll read it the same way. 1 meter equals 1 meter. 1 meter equals 10 decimeters. 1 meter equals 100 centimeters. 1 meter equals 1,000 millimeters. So one decimeter, because it takes 10 of those to make a meter, just one of them is 1/10 of a meter. 1 decimeter is 1 decimeter. 1 decimeter is 10 centimeters. 1 decimeter is 100 millimeters. And then 1 centimeter, well, we can see up here it takes 100 centimeters to make 1 meter. So 1 centimeter is 1/100th of a meter. 1 centimeter is 1/10 of a decimeter. 1 centimeter is 1 centimeter, and 1 centimeter is 10 millimeters. Now it takes 1,000 millimeters to make 1 meter, so 1 millimeter is 1/1000th of a meter. 1 millimeter is 100th of a decimeter. 1 millimeter is 1/10 of a centimeter, and of course 1 millimeter equals 1 millimeter. Let's try another problem. Sharon is working on a project for art class. She needs to put strips of wood that are each 1 decimeter long to complete, she needs to cut strips of wood that are each 1 decimeter long to complete the project. If Sharon has 7 strips of wood that are each 1 meter long, how many 1 decimeter strips can she cut? Will you take a few moments to fill in the boxes on the top of the read the problem, then check back. So what is it that I need to find out? Well, I need to find out how many 1 decimeter lengths of wood Sharon can cut. And what information do I need to use? I need to use the number of meter strips. Remember, she had 7 of those. And the number of decimeters in 1 meter. Well, one meter equals 10 decimeters, so that would be 10. How will I use the information? I will make a table to show the relationship between the number of meters and the number of decimeters. So here's my table. I'm comparing the relationship between meters and decimeters, and I know that 1 meter equals 10 decimeters. So I could build my table on out. 2 meters would equal 20 decimeters. 3 meters would equal 30 decimeters. All the way up, I'm just going to use this because we've used that in 5th grade math and we know how that works. I've got enough information here. I know my rule. This would be 7. I've got 7 meter strips, and so how many pieces, decimeter size pieces, will that cut? Well, if I look at the rule here, too much table. All right, if I look at the rule, from meters to decimeters, I can see that my rule is multiply by, if I'm going from 1 to 10, I'm multiplying by 10. And so 7 times 10 is 70. So Sharon can cut 70 1 decimeter lengths to complete her project. Look for a pattern. What relationship did the table you made show? Well, it showed the relationship between meters and decimeters. And 1 meter equals 10 decimeters. Use diagrams. How could you use a diagram to solve this problem? Pause the video to think. If I were drawing a diagram, I could draw 7 rectangles to represent my 7 meters and then divide each of those into 10 pieces, or I could just simply think about each one of them has 10 decimeters in it, and therefore 7 meters equals 70 decimeter pieces when they're cut in decimeter sized pieces. Go ahead and work through problem number 1 and then check back. Let's quickly take a look at the last two. What if Edgardo fills the cooler with only 32 quarts of water? How can you use your table to find how many gallons that is? Well, if I make a table comparing quarts to gallons, and I know that 1 quart is 1/4, I can take my table on out. Find the rule is multiply by 1/4. So I have 32 quarts of water times 1/4, and that would be 32/4, or in the end 8 gallons. And number 3, how would the number of times Edgardo uses a container to fill the 10-gallon cooler change if he used 1 cup container? Well, the number of times he has to fill the container would be greater since there are 4 cups in 1 quart. So if I'm thinking about converting from quarts to gallons, in 10 gallons there are 40 quarts, and in each of those quarts then there are 4 cups. That would be 160 times. I think it's easier to see it if you simply make the table. 1 gallon equals 16 cups, so 2 gallons equals 32 cups. We can take that on out to 10 gallons would be our rule. Going from gallons to cups is multiplied by 16, so 10 times 16 is 160. You do have an online assignment for today. Please remember to do spiral review, and I'll see you back next time for lesson 10.7.